Dear students, today I want to revise the very important topic oscillations. We can just revise the simple terms in related with oscillation. At first, you should know the difference between the periodic motion and oscillatory motion. The periodic motion, the repeated motions only in a regular interval of time. But oscillatory motion means it must be to and fro or back and forth. Look the examples. The motion of planets around the sun, the motion of pendulum wall clock are examples for periodic motion. But the oscillation of the mass suspended from spring or vibration of the wire of sitar are good examples for oscillation. See, in our point of view, the very important concept is a motion is said to be harmonic. Only it can be expressed as a sine or cosine function. Look the graphs for sine and cosine. And here it is given a non-harmonic function. Even though it repeats at a regular interval of time, it is not harmonic. Your comfort with the simple terms with the oscillations. Just move towards a confusing one, the phase. The phase, and here the y is equal to a sine omega t plus phi. There is a general relation. If a body starts from the mean position, and here if it starts from extreme position, it can be expressed as a cos omega t plus phi. Here omega t plus phi represents the phase angle. At a time t equal to 0, it is called the initial phase or epoch. And here the two situations are there with amplitudes A1, A2, with the phase omega t plus phi 1 and omega t plus phi 2. Then simply the phase difference is omega t plus phi 2 minus omega t plus phi 1. You get the value phi 2 minus phi 1. These two important concepts. Look, the two vibrating particles are said to be in same phase if the phase difference between them is an even multiple of pi. Even multiple as 2 pi, 3 pi, like that. Two vibrating particles are said to be opposite phase if the phase difference between them is an odd multiple of pi. That means of the order of pi, 3 pi, something like that. So it is very important. So here the 2n plus 1 or minus 1 is applicable. See, the simple harmonic motion are of two types. Along a line we can say as linear. In a circular arc we can say angular SHM. In both of the situations we have to apply the different concept. The restoring force should be proportional to displacement. That is a very important concept. In linear motion we have to take like this one, F proportional to minus Y. But here the torque tau proportional to theta. Look, the general relation, the d square x by dt square plus k by m into x is equal to 0 with the time period t is equal to 2 pi into root m by k. The very important concept. Look, the angular SHM, and here the general relation and the time period. Very important concept. We can go with the two important previous year concepts. Which of the following functions represent SHM? Look, here the first we have to prove acceleration is minus a constant into x. So that is a concept. If you can prove it, then we can say it is SHM. Look, the first one. The displacement is given. We can just find the velocity. Then again differentiate it. You get the acceleration. You get the value minus 4 omega square sine 2 omega t. And you can substitute for sine 2 omega t as y. So equal to minus 4 omega square y. So that is a SHM. Good. But look the next one. Y is given as a sine omega t plus 2 cos omega t. If you just differentiate, again you get the acceleration. You just take the minus omega square in common. into sine omega t plus 2 cos omega t, but it is our y term. So we can say it is again SHM. Look the third one as y is equal to sine omega t plus cos 2 omega t, dy by dt equal to omega cos omega t minus 2 omega sine 2 omega t. Again differentiation, you get the acceleration, but the bracket is not the displacement y, and hence it is not SHM, but it depends upon the sine or cos function. We can say it is oscillatory. Look the good question you can do. If we are with the two SHMs as y1 equal to 10 sine 3 pi t plus pi by 4 and y2 equal to 5 into sine 3 pi t plus root 3 cos 3 pi t. Find the ratio of their amplitudes and phase difference in between. We can solve it simply. You have to convert these two into the same function as that of sine of theta. For that, you can just cross it and you get a 5 sine something plus 5 root 3. You can just substitute as 5 is equal to a cos 5 and 5 root 3 as a sine 5. Then you get the a1 as 10 and a2 as 10, and you get their ratio is 1:1, and we can write the phase difference as pi by 12 radian. The next very important concept, look the displacement x is equal to a sine omega t, and keep in mind the time is measured from mean position. If it is from extreme, you have to substitute as x is equal to a cos omega t. Look the velocity function, you have to differentiate it as d by dt of a sine omega t. You get the value as v equal to a omega cos omega t, and in terms of x we can write equal to omega into root of a square minus x square. If you just arranged it of the form, so it will show it is an ellipse. So the graph between displacement and velocity is ellipse. And look at the graph. At the mean position, the x is equal to 0, the velocity is maximum, take the value a omega. At extreme position here, the displacement is x is equal to plus or minus a, but the velocity is 0. Good concept. Acceleration, we can write as minus omega square a sine omega t or equal to minus omega square x. So a equal to a constant into x. So the graph is a straight line for acceleration versus displacement. Look here and keep in mind the acceleration of a particle executing SHM is always directed towards the mean position. The acceleration become maximum. At extreme position got the value as omega square a. At mean position you get the value as 0. Look the different graphs with respect to time for displacement, for velocity. That velocity is a omega cos omega t, acceleration and force. Look the graph. There is a phase difference of pi by 2 between x and v. But there is a pi phase difference between x and acceleration because of the minus sign, and x and the force. Good concept. And here with a good question, a particle execute SHM of time period t. Find the time by the particle to go from its mean position to half of the amplitude. And here you know as x is equal to a sine omega t. And it is given as x take the value as a by 2, that is equal to a sine omega t. And you can just write for 1 by 2 as a sine pi by 6. So that pi by 6 take the value as omega t. Omega t is nothing but 2 pi by t. So you get the value for t is equal to t by 12. And we can move to the next one. A good question is waiting. The two particles move parallel to x-axis about the origin with the same amplitude and frequency. At a certain instant, they are found at a distance a by 3 from the origin on opposite sides, but their velocities are found to be in the same direction. What is the phase difference between the two? So, look the procedure. We know x1 is a sin omega t, say, then x2 can be written as with a phase difference phi. So it is given a by 3, but in the second case it is opposite and hence minus a by 3. So from that, sin omega t is equal to 1 by 3. But here the sin omega t plus phi s minus 1 by 3. Then you can just use the concept of sine of a plus b. So you can solve, we get the two relations as cos phi is equal to minus 1 or 7 by 9. And if you just take the velocity concept, if we could put the value as phi is equal to pi, but here the v1 and v2 are of opposite sign. But here it is given in the same direction. So we can take the value as a cos inverse 7 by 9. A good question. Look again. A particle executing XHM with a time period t and amplitude a, the mean velocity of the particle averaged over quarter oscillation. Look the choices, and you know x is equal to a sin omega t, v equal to a omega cos omega t by just differentiating. Look the common formula. We have to take over quarter, so 0 to t by 4 v dt by the total time. So we just substituted for v, that is a omega cos omega t. Integrate between the limit 0 to t by 4. So you get the answer. And another variety question. The velocity of a particle in SHM at position x1 and x2 are v1 and v2 respectively. Determine the value of time period and amplitude. Look, at x1 we can write v1 square equal to omega square into a square minus x1 square. And at x2 we can say as v2 square equal to omega square into a square minus x2 square. Then just we get the value for omega is equal to root of v1 square minus v2 square by x2 square minus x1 square. From that we can find the time period. If you just divide the two relations, you get the value v1 square by v2 square is equal to a square minus x1 square by a2 square minus x2 square. We get the value amplitude. A simple question is waiting. A particle executing SHM having amplitude 0.01 meter and frequency 60 Hz. Determine the maximum acceleration of the particle. So it is nothing but omega square a. Omega is what? 4 pi. You can substitute omega is as 2 pi n. So 4 pi square n square a. So we get the answer. So we know another concept, the very important, energy in simple harmonic, the potential energy in terms of x, in terms of time. You can have it to substitute as x is equal to a sin omega t. So half k a square sin square omega t. Then what is k? That is very important. So we can discuss later. See, it is proportional to x square and hence the graph is a parabolic. Look the graph. The u is a minimum at mean position, maximum at extreme position. So it is minimum at t is equal to 0, t by 2, t, 3 by 2, t, etc. But maximum at t is equal to t by 4, 3 t by 4, like that. The kinetic energy, it is nothing but half m omega square into a square minus a square. That is labeled as half k into a square minus x square. That k, that is nothing but m omega square, keep in mind. So, and again it is a parabolic curve. The kinetic energy is maximum at mean position, minimum at extreme. Look the time. The maximum at t is equal to 0, t by 2, t, 3t by 2. The minimum at t is equal to t by 4, 3t by 4, 5t by 4. Look the total energy curve. We have to find the average and the average kinetic energy and the potential energy for one cycle. Look the formula. Integral 0 to t. That energy into dt. That division by the total time. Similarly, you have to take the potential energy. You get the relation 1 by 4 m omega square a square for both the terms. Another very important concept. The frequency of potential energy or kinetic energy is double than that of SHM. So, in the normal cases, the displacement or velocity or acceleration got a frequency of omega. But if you just substitute for sine square omega t as 1 minus cos 2 omega t, from that you can reveal one thing. It is not SHM but also oscillatory with a frequency of 2 omega. Waiting a good question. A particle execute SHM. What fraction of total energy is kinetic and what fraction is potential when displacement is 1/2 of the amplitude? At what displacement the kinetic energy is equal to potential energy? See, simple calculation. At x is equal to a by 2, the kinetic energy can be write as half omega square into a square minus x square. So x take the value as a by 2 square. So a square minus x square take the value 3 by 4 a square. But we know half m omega square into a square as the total energy. So kinetic energy by total energy is equal to 3 by 4. The potential energy at x equal to a by 2, take the value half omega square a square by 4. The second question is kinetic energy is equal to potential energy. So half omega square into a square minus x square. So we get the value x is equal to a by root 2. Look the important different concepts with the spring pendulum. It may be horizontal or vertical. We have to use the simple concept as t is equal to 2 pi into root of inertia factor by the spring factor. So it is root m by k. But keep in mind we have to use one assumption. The spring is massless unless it is stated. If it is stated so, you have to use the concept as t is equal to 2 pi into root of m plus ms by 3 by k. A good aspect. And keep in mind, we already discussed the concept, but when a spring of length L is cut into two pieces of length L1 and L2, if it is given as L1 equal to NL2, if the constant of the spring is K, then keep in mind the spring constant of the first part K1 is K into N plus 1 by N. The spring constant of the second part as K2 is equal to N plus 1 into K. And the ratio of spring constant is K1 by K2 equal to 1 by N. A good aspect, keep in mind. Look the different concepts. And here, the restoring force minus Ki, the time period is simple. But the case is entirely different if the spring takes the position here. Already you know if it is with the tension, the double tension is here, and hence the displacement become half. If it is with y, and here it is with y by 2. So there is a concept we have to use here. So the extension in the spring become y by 2. So the tension become k into y by 2. So the restoring force become half of so much. You get the concept. 2 pi into root 4 m by k. Good concept, good J-main concept. Look the next addition. The spring is here. And here it is y. The displacement here it becomes 2y. That is a very important one. And keep in mind, always the extension into tension is a constant. Always the velocity into tension is a constant. Always the acceleration into tension is a constant. Virtual work method, that is another concept. So here, F is equal to, you get the value. But if the two masses are connected with a spring, then it is under SHM. And keep in mind there, the formula is 2 pi into root mu by k. But what is mu? The reduced mass. The reduced mass. Look the next question. The periodic time of oscillation T1 is obtained when a mass is suspended from a spring. If another spring is used with the same mass, then periodic time of oscillation is T2. Now, if the mass is suspended from series combination of above springs, then calculate the time period. We know for the first case T1 equal to 2 pi into root of m by k1. We can write 4k1 as then 4k2. But in series combination, 1 by k equivalent is equal to 1 by k1 plus 1 by k2. But for parallel as k equivalent is k1 plus k2. But here series, you can just give this concept, you get the answer. A very important question is waiting. A particle of mass m is attached to the three identical springs, each a force constant k. If the particle of mass m is pushed slightly against the spring A and released, the time period of oscillation. So it is. So that is very important. So the restoring force of Fa. But these two, we have to take the component responsible for that. So we have to split that one. So that is a very important one. Look the figure carefully. So it is pushed downward. So each spring got in this concept as y dash displacement. But that displacement, it should be taken in the same direction of the A spring. So that is, we have to take as FB cos 45 and FC cos 45. So you can just substitute it for y dash is equal to as y cos 45. So you get the value as minus 2ky. So we get the time period is equal to root m by 2k. Look the simple pendulum. Actual relation is t is equal to 2 pi into root of 1 by g into, in the denominator 1 by L plus 1 by R. But in the normal cases, we are taking an assumption and that if L is very much less than R, compared to that R, 1 by R can be neglected. We get the relation as t equal to 2 pi into root L by G. But if L is very much greater than R, that is said to be the infinite pendulum. There the time period become 84.6 minutes. But if L is equal to R, it takes just 1 hour. And keep in mind, L is the effective length between the point of suspension and the center of mass of the object under consideration. The effect of temperature on length, you have to substitute as L is equal to L0 into 1 plus alpha delta theta. Linear expansivity term, that is alpha. If the bob of a simple pendulum of density rho is made to oscillate in some fluid of density sigma, the gravity will change and hence the time period. It is a very important concept. You must think about the pendulum in a lift. It is a constant velocity g itself, but moving upward with an acceleration a, g plus a, downward with an acceleration g minus a. Another concept, if downward with an acceleration g, freely falling in the sense, the time period become infinite. That means no oscillation. The time period of a simple pendulum whose point of suspension moving horizontally with an acceleration. So in that g effective become root of g square plus a square. It's a very important concept. Look the different graphs. Second pendulum, it is very important. Its time period is 2 seconds. The length become 99.3 centimeter. If you substitute g as 10, we can say as 1 meter. A simple pendulum of length L having a bob of mass capital M is suspended in a car The car is moving in a circular track of radius capital R with a uniform speed v. If the pendulum makes small oscillations in a radial direction about its equilibrium position, what will be its time period? And here the two accelerations at a time, the centripetal and g. So we have to take, they are mutually perpendicular as root of g square plus v square by r the whole square. The length of a second pendulum at the surface of earth is 1 meter. Then we determine the length of the second pendulum at the surface of moon. So here, keep in mind, the gravity on moon is 1/6 of earth. Therefore, the length become L by 6. The next concept, the damped oscillation, a very important concept. The damped oscillations, the general differential equation, m into d square x by dt square plus kx plus b into v. And keep in mind, here the b is the damping constant and the damping force is proportional to the speed here. And the solution, keep in mind, the very important concept, look the amplitude as a0 into e raised to minus bt by 2m. And look the angular frequency root of k by m minus b square by 4m square. Look the energy in a damped oscillation. The very important question is waiting. The amplitude of a damped oscillator become half in 1 minute. The amplitude after 3 minutes will be 1 by x times the original. Determine the value of x. Look the procedure. We know the amplitude as e raised to a0 e raised to minus gamma d, where we put the value gamma as b by 2m. At t equal to 1, you can write this one. At t equal to 3, we can write a0 by x is equal to, so you get the answer as 8. The physical pendulum, an extended object, is under oscillation with a point of suspension. If its center of mass is at a center of gravity at a separation d from the point of suspension, we can say t equal to 2 point root of I by mgd, where I is the moment of inertia. But if you just consider in the simple pendulum, you have to substitute as I equal to m into d square, you get the value. The next concept, torsional pendulum. As t is equal to 2 point root of I by k, keep in mind k is the torsional constant. An object, it is just hang with a string and is under rotation. Look the very important concept. The motion of a liquid in a V tube when it is slightly depressed and released. If it become U tube, you have to just substitute that theta 1 equal to theta 2 equal to 90. You get the simple concept. When a partially submerged floating body is slightly pressed and released, the time period take the value as t equal to 2 pi root h by g. Motion of a ball in a tunnel or a cord in earth, the infinite pendulum, got the time period of 84.6 minutes. So try to solve maximum MCQs and have a lot of chances for coming NEET and JEE main examination based on this concept. God bless you. Thank you.